All right, so today's lesson is on compounding continuously. So we've explored compounding annually, quarterly, monthly, weekly, and even daily. All right, but what if something compounds continuously? So first question is, what does that even mean? Okay, what does the word continuous mean? So when you're thinking of something that's compounding continuously, all right, take a second, type in what you think. All right. So it means that it is always continuously, every millisecond. It's constantly compounding upon itself. So like when bacteria is growing, right? It doesn't compound quarterly, like stays the same, then all of a sudden, 3 months later it doubles, right? It's constantly growing. Okay. And so that's what we mean by continuously compounding. Okay. Always compounding every nanosecond. All right. Uh, how would we fill this formula in if something is compounded continuously? And so the formula she's talking about is this one right here. Um, so we know this as our compounding, right? Where n is the number of times. So if it's monthly, n would be 12. T is still number of years. So right, if it was 4 years, it'd be 48 months. How many times it's being compounded ends up being. Okay, the interest rate is still the annual rate. Okay. So what would n be if we were compounding continuously? And n would be infinity. All right. And so it's constant. So we can't use this formula. Okay. So, n would be infinity, which means this formula will not work. All right. And so, um, from our group project, whose account balance from the interested worksheet would be closest to continue? So the most that we did was daily, right? And so if you look back at that, I believe it was Anthony was compounded daily. So his would be the closest, okay, because that was the most frequently compounded. All right, so since we know that that formula won't work, we've got to come up with something different. All right, and so we're going to learn about this new number. Okay, there's this new number, and the number is E. All right, another letter just like pi. Okay, E. Okay, it is real. It's irrational. It's 2.718 and continues on forever, never repeats. So it's an irrational number. All right, so it was discovered by Leonard Euler, um, and so he named it E because that's what his name started with. So there we go. That's what it is. I got a little link in the Canvas here, um, kind of explaining to you where the E comes from and how it's related to the interest and compounding problems that we've been working with. So take a second to watch that video if you want to learn where this number comes from. One place. It's actually comes from a couple different proofs. All right, so here's the formula that we need, okay? So we know the other one doesn't work because we can't plug in infinity. So here's the new one. I just always reference this to as the PERT formula. So you remember it, P-E-R-T. It's P, the principal amount, times E, the new number we just learned about, raised to the RT. So the interest rate, that annual rate, is being multiplied to the number of years, okay? If it's annual rate, number of years there. And that's it. You just plug that in and we can calculate it. Because remember, we obviously need a calculator to do this. Okay? Every calculator has the number E on it. And so let's take a look. All right, and here's just a website for you guys to explore. Um, go. It kind of, again, shows that proof, okay, of where the number comes from. Okay, this relates to that video. All right, so here's the worksheet you guys did with your groups. Okay, all right, we did Justine's compounding monthly. We skipped that one. We didn't do the bi-monthly one, but we did Anthony doing compounded daily. So we have both of those from our worksheet. Okay, how much will he have after 16 years if compounded continuously? Okay, so now we want to use our formula. All right, and so we have our 2,000. So A of 16 is going to be 2,000 times E raised, again, it's 5% raised to the 0.05 times, and it was 16 years, times 16. All right, so let's type that into a calculator. 2,000 E raised, again, I just typed in E on my keyboard, raised to 5% times 16. And so the amount is $4,451.08. 4451.08, I believe. 0.08, yes. All right, so not much more than compounded daily, but still a little bit more. All right. So what's the difference? We just subtract it. It's what, 24 cents. So, All right, so now you guys are gonna try these, okay? Again, let's just kind of set these up and then we'll type them in and on the calculator. So everyone, okay, is gonna be 4,000 is the principal amount. These are all compounding continuous. Okay, so E, and that's going to be 0.03 times 5. Again, I got to get a thinner marker here. Okay, and then the other one, so it's going to be the same thing over and over again. We're just changing the years. I do want to show you this. All right, just to see. What these are. So the formula is pretty easy to use, okay? And so we're just gonna come over to Desmos, we'll set it up, it's 3%. And so now all we have to do every time is just change the year. So the first one was 5 years. All right, so we get 5,809.17. All right, so we come over here, 5,809.17. Again, it's money, so we always round to the nearest hundredth. All right, and then we just come back, we change this to an 8 after 8 years. Now it's $6,356.25. 6,356.25. And now 20 years. Now we're talking 12 more years. Okay. It's going to keep growing. That amount's going to grow for another 12 years. Okay, so let's do that. Change this to a 20. Now I've got 9,110.59. 9,110.59. And then 35 years. So for another 15 years more. Now it's 14,288 and 26 cents. So you can see that it's growing and growing. The longer you could wait, the more it grows. And then this is at a 3%, which is not a very good return. I mean, it'd be good if you can get that guaranteed safe, but right, you can make a lot more than that if you invest smartly in the stock market and stuff. So. All right, how do you know when to use this formula? So you use it, okay, when it's compounded continuously. All right, under what conditions will the compounding one be the same as the original one? So when n is 1, right? So when n equals 1, or when it's compounded annually. Anytime it's compounded more frequently than annually or slower, then it'll be different. But when n is 1, it's the same. All right, so here's an exit ticket. So 60,500 at a rate of 2.5%. Okay, and then we're gonna do it for 5 years, and just each one is compounded differently. So all we're gonna do here is set this up, and you guys can type into your calculators. So if it's compounded annually, yearly, once a year, right? That's the first one. So that we talked about a couple weeks ago. So our principal amount, 60,500, 1 plus R, so 1 plus 2.5%, so 1.025 raised to the 5th power. All right, now it's compounded monthly. Okay, I need the monthly rate. So it's going to be the annual rate divided by 12. So 60,500 and 1 plus the monthly rate. So 0.025 divided by 12. And now that, how many times is that compounded? So for 5 years, okay, it is compounded 60 times. 5 times 12. So that's a formula. You just type that into your calculator. And then if it's compounded continuously, so now I'm going to use the PERT formula. Principal 60,500 times E raised to 0.025 times 5. All right, and if you type everything in right, this will be the smallest amount, and this will be the largest amount. All right, and so that's how you would do. You just got to pay attention to how frequently it's being compounded. Make sure you're using the right formula, and the calculator does the rest of the work for you.